My name is Lucas Wilgosh. I am the Vice President of Drones and Geomatics at Measure, and I will be presenting the webinar today for everybody. We do have a couple of other Measure staff on, the admin side of the webinar. So as you guys have questions, just please send them into the chat there, and then we'll either get to them at the end, or if we have no more time, we'll, send some emails out to everybody. Now, we really want this webinar to be really short, concise, and just cover the meat and potatoes of what we want to get to. So we're going to try to keep it around that 30-minute mark. We may be less, we may be a little bit more. So if you guys have other things to go to, don't worry about breaking off early. So a couple of house rules that we want to just go over quickly. Please make sure you turn off your camera and your microphone. I think we already blocked all access to you guys anyways, so you won't be able to. Feel free to type your questions in the chat box, and then at the end of the presentation, we will do a quick Q&A, depending on time permitting and what the questions are. Now today, on this learning checklist, we want to go over a couple things. So mainly, we really want to cover what is the Trinity, what is the Qube 240 LiDAR, what is the processing workflow from mission planning to flight to post-back in CloudStation, getting actual deliverable. Then we'll go over a couple of case studies, and then we'll go over what comes in the box, pricing, and any questions after that. So let's just get started here right away with the Trinity F90 Plus. But first, let's talk about Measure. So if you guys any of you guys who are unfamiliar with Measure, we have 4 offices in Canada: Calgary, Burnaby, Toronto, and Montreal. And we do have 3 full divisions: drones, geomatics, and materials testing. Now, we are expanding heavily in the drone industry, and that's kind of where this webinar fits into our realm. But a couple things about us on the drone end: we do have sales and support staff across Canada to help you in all of our offices. But most importantly is all we do is focus on selling you product and supporting that product. So we are not a service provider. We do not perform services in the field and compete against our customers. All we want to do is sell you product and make sure you're up and flying, train you on that product, and then support that product in the field. So that's all we are here to do for you. So who is Quantum Systems? If you guys are unfamiliar, they were founded in 2015 in Germany. They're a German company. They are still fairly young. They're a manufacturer of VTOL fixed-wing drones. They have 80 plus employees. Actually, now they're at around 100 plus employees. So they're growing really rapidly. And what's most unique about Quantum Systems is that they have a self-developed flight planning software, and they develop their own autopilot software. So this is crucial because they do updates and can do any sort of bug fixes really, really quickly, because everything is coded from the ground up by the Quantum Systems team. Now let's just go over a little bit on the Trinity F90 Plus. So maybe you already have a Trinity, or maybe you don't have a Trinity. Maybe you have a competing fixed-wing VTOL or another fixed-wing in the market. We're going to go over a couple of the biggest features on the drone. So the most obvious one is the vertical takeoff and land. So this is crucial for fixed-wing drones nowadays. It allows you to take off in confined or difficult to reach spaces. So forest service roads, mines, anywhere where there's a narrow pathway, and a belly landing drone will not basically land without crashing. The other advantage to the Trinity in particular, due to its 3-motor system, is there is no tipping on takeoff or land. So unlike some other VTOL systems that are 2-motor systems, tail sitters, the Trinity will not land and tip at all. It's just going to land nice and safely no matter what. The other thing is, we want to take off from the transport case or the ground. They recommend off the transport case just to keep the sensor nice and clean, but you can take off from virtually any environment. Doesn't matter if it's a 40-degree angle, the Trinity will still take off. And we can also hand catch the drone if needed in very emergency situations, or something like a mine site where there's really jagged rocks on the ground. So flight time. So this is obviously the biggest selling feature of the Trinity F90 Plus. It comes standard. Every package comes standard with 90 plus minutes of flight time. Now, with the Qube 240 LiDAR, they do limit us to 60 minutes, and that's just due to the obviously weight of it, but also the higher power draw from the LiDAR sensor itself. So 90 plus minutes with any other payload, about 60 minutes with the Qube 240 LiDAR payload. Now, what's interesting is if you look at the area in one flight section at the bottom left there, with the Qube 240 LiDAR at 100 meters AGL, which is our recommended height, and we'll get into that in a little bit later, you can still cover about 200 hectares at a 50% side overlap, which is fairly standard for LiDAR. In comparison, if you look at something like the RX1R2, the 42 megapixel at 120 meters AGL and 75-75 overlap, you get about 170 hectares Whereas the Sony UMC, which is a 20 megapixel payload, you get 230 hectares at 120 meters AGL, 75 overlap. So you can see even with less flight time, because the field of view is wide enough on the LiDAR and our overlap does not have to be the same as photogrammetry, we can cover a very, very large area. Now, in terms of weather constraints, it's 9 meters per second wind on takeoff and 12 meters per second on cruise mode. So, and when you take off the drone in hover mode, if it's over 9 meters per second, it will not let you take off. That's just the weather constraints, and vice versa in cruise mode. If you get constant readings over 12 meters per second, the drone will automatically return home to you for safety. Operating temperature is -12 to 40 degrees Celsius. We're currently doing cold weather testing with some customers in Canada to lower that official operating temperature down to about that -20 degrees Celsius. So what's a big advantage to the Trinity? Well, it's modular. So it's easily assembled and disassembled in under a minute. The wings, tail, elevator, payload, battery, everything just simply clicks in and then clicks out. So it's really easy to put together, but it also gives us really affordable repairs if anything happens with our wings, someone steps on it, you clip a branch, anything like that. Also with the Trinity, replacement parts can easily be fixed in the field. It doesn't really matter if it's a propeller, if it's a motor, even servos. We can do this all in the field or at the customer's office, or measures techs can do that all for you guys. So it's really easy to get the Trinity up and running and sustain a really long lifetime. So best in class sensor capabilities. So the Trinity comes loaded with the absolute most payload compatibility of any fixed wing drone on the market. In terms of RGB sensors, you can either go to 42 megapixel RX1, R2, really high resolution. At 400 feet, you get about 1.5 centimeter GSD, or you can do the 20 megapixel Sony UMC for a little bit lower GSD, larger area coverage, and lighter file sizes. Now, for multi-spectral data, they are integrated with the Red Edge MX, the Ultim, the Red Edge Dual, and they also have a dual payload with the MX and Sony UMC, so you get high-resolution RGB and multi-spectral. And very, very shortly, the new MicaSense Red Edge P and Ultim PT will be released for the Trinity, and it'll be completely backwards compatible, so any customer's Trinities from basically at spot at any point in time until now will be compatible with that. There's also the FLIR-Tau 2 plus Sony UMC thermal sensor, which is being released very shortly as well. And then lastly, the Qube 240, which is obviously the most unique payload for any fixed wing drone, VTOL drone in its class, is on the Trinity F90 Plus. I do have some, these videos are playing, so I don't know how laggy it is on your guys' end, but hopefully not too bad. Every Trinity comes standard with an iBase GPS base station at no extra cost. So even with the price of a Trinity, you get this GNSS base station no matter what. It can be used to PPK process every Trinity F90 Plus payload, including the Qube 240. It's a very entry-level L1, L2, L5, GPS GLONASS Galileo, U-Blocks receiver. You have about 10 hours on a single charge. So obviously when you're on the field, for best accuracy, I recommend placing the iBase over a known pin, or you can EnterCam PPP it, your raw base data, and get your corrected base location after that as well. Now, it's important to note that all Qube 240 and all the rest of the Trinity F90 payloads can be PPK'd through any third-party base station. So it doesn't matter if you have StoneX, Trimble, Leica, Topcon, as long as you can get a Rhinix file and convert it to a Rhinix file, that's all we need at 1 hertz. Now, here's a good little graph I like to show everybody, just some comparisons to some other fixed-wing drones on the market. Anything in blue is what we deem as an advantage. So we obviously have competitor number 1, which is another fixed-wing VTOL, and then competitor number 2, which is a belly landing drone. So obviously the VTOL is going to be advantageous for basically every single scenario. In terms of flight time, the Trinity has 90 plus minutes of flight time. So the reason we mark that as blue over something like competitor number 2 is because that 90 plus minutes is included at no charge and no additional modules or anything like that with the purchase of a Trinity. And of course, 60 minutes is with the Qube 240 LiDAR. Payloads, as we just went over, there's really no competition on why the Trinity has the best payload array in the market. Modular design is obviously advantageous for repairs, ease of use, transportability, really everything. And then remote control is really important. That's often overlooked. With the Trinity, a remote controller is included, and you have assisted RC control at all times for maximum safety. So they're unlike competitor number 1 that has virtual joysticks on a tablet, or other fixed-wing drones that they don't recommend use the RC at all or don't even give you them. the Trinity always has it for basic backup safety in case you have to maneuver manually on hover takeoff, landing, or in cruise mode. You have all the options. PPK does come completely standard with the Trinity at no extra cost. And then ADS-B, so the Trinity comes standard with ADS-B in included, whereas ADS-B out is also an optional add-on that can be configured from the manufacturer. So you have lots of ability to customize your drone how you see fit. And then lastly, for a base station, the Quantum Systems includes the iBase GNSS reference station with the Trinity F90 Plus, but you can still third-party process it with any GNSS base stations as well. Perfect. So let's go over a little bit on the Qube 240 LiDAR sensor itself. So first of all, how did this come apart, or how did it come together? Really, it was a partnership with YellowScan. So it's kind of worked out really nice for us because we are a YellowScan dealer for all of Canada. And so basically Quantum Systems and YellowScan worked together on their Mapper Plus system, and they basically OEM'd it, made it as light as possible, removed any of the camera add-ons and the extra weight, and fit it into the Trinity F90 Plus. So you're getting the reliability of a fixed-wing drone from Quantum Systems, as well as the reliability of YellowScan, one of the largest LiDAR integrators in the world, working together. So why LiDAR before we get into everything? And I know most people are fairly familiar with it, but essentially LiDAR is a remote sensing method that uses light in the form of pulsed lasers. So we're essentially using lasers to measure distances to the ground. Now, why is LiDAR beneficial? Well, we get high vertical accuracy in areas with dense vegetation, which is traditionally very, very hard to do with photogrammetry, and in certain areas impossible to do with traditional survey techniques. We also get accurate terrain models in these areas. And then it's really beneficial in sites with low visibility or poor lighting. So because it's a laser technology, we don't need exact proper lighting conditions from the sun. And it's not going to mess with our data at all. We can fly in low lights, highlight anything. The other benefit to LiDAR is it allows us to capture details really small in diameter. So if you're trying to catch really finite details like a power line, LiDAR is going to be your only bet to really get a high point density on those lines and properly reconstruct it. LiDAR also has a faster processing time. And so now obviously this varies depending on a multitude of variables, but in general, we can quickly in the field process our LiDAR really quickly to make sure that A, our elevations are accurate, B, we covered all the necessary area that needed to be. And so it's really, really quick and easy in the field to do that. Lastly, we can map non-linear areas due to a larger field of view. So for customers who want to do, urban mapping or maybe erosion mapping, something where there's a steep wall that we need to map in photogrammetry may not be the best bet, especially with the Nadir 90 photogrammetry setup, then LiDAR would be really good due to the wider field of view. Now, fixed-wing drones versus multi-role drones, we get this asked all the time. Why would I want LiDAR on a fixed-wing drone? And obviously, the biggest point is more area coverage. You can cover substantially more area because your fixed-wing drone's flying faster, flying longer, and flying farther. Traditionally, you also get straighter flight lines on the fixed-wing drone. You also get smooth turns when it's banking. There's no stopping like a traditional multi-copter. I know, if you use something like UGCS, then you can obviously correct this, but this keeps the IMU initialized and minimizes the risk of your IMU drift. And then a non-gimbal mount also keeps our lever arm measurements set, improving our data quality. So just some general LiDAR specs. It is running a Livox ABS sensor, and yes, that is the same sensor that is in the DJI L1 and a multitude of other LiDAR integrations. It has a 70.4 degree horizontal field of view and 240,000 points per second. So what's really unique about this is with the 3 echoes, because it's tied with the Planix APX15 INS, is we get really, really high accuracy because of the quality of that calibration and the bore sight calibration, how tightly coupled everything is from YellowScan. So the typical mapping accuracy, they say about 2 centimeter precision, 3 centimeter accuracy, and that is tested at YellowScan and Quantum Systems facilities. But I would say you're likely around the 3 to 5 centimeter mark on an average day with all the variables that can go into it. So why integrate the Livox AVIA rather than, again, a number of other sensors on the market? Well, it's a fixed state LiDAR, so it's not a rotating puck. So what this means is even though it's 240,000 points per second, those are all shots straight down. We're not losing any stray points to the rotating puck and cutting them out. So we get a really high point density while still flying at higher speeds due to the fixed state sensor and a narrow field of view. So the AVIA and on the fixed wing or a multi-copter, it's really going to give you really dense point data flying at higher speeds. So again, we have the Planix APX15 INS integrated. That's a Trimble company with a really high IMU precision. And with it, we really recommend about a 50% overlap and 100-meter AGL. Now, we do have customers who can cut that overlap down to 40 to 30, really depending on what you want your point density to be and what your terrain is. But we recommend 50 as a standard. What's important to note, and we get asked this a lot, is that the Qube 240 is only compatible with the Trinity F90 Plus. It is not, you cannot take it out and mount it on something like a quadcopter. In the video there, if it's playing well for you guys, you can see that GNSS antenna is sitting on top of the Trinity. So the Trinity actually has a little module that sits on the top where we mount either the LS2 light sensor or this Trimble antenna. And it's just a magnetic mount, and it's used and really you can click it on really easily and get running very, very simply. So you can switch payloads really in the field in seconds. So here's a good graph on point density by ground speed and altitude. The swath of the Qube 240 is approximately 1.4 times the flying height. Now, with a fixed wing drone, we have to really be careful of headwind or tailwind. So this all comes down to flight planning. Obviously, we want to plan crosswind as best as possible. But if you have headwind or tailwind, then obviously that's going to increase and decrease our point density. And we want to, make sure that's as balanced as possible. Vegetation, slope, reflectivity all affect this quite heavily. You can kind of see at that 100 meter at 17 meters per second. So our Trinity flies at about 18 meters per second set. We're at that about 92 points per square meter. And remember, that's 90.2 points or 92 points per square meter on your entire LiDAR data. That may not necessarily be your final terrain data, your DTM export out of there, because that's going to, vary depending on conditions. So the Qube 240, because it's a self-sufficient standalone system, it is powered by the Trinity itself, but the operation is completely independent from the Trinity. So it's completely self-sufficient. So we have a stat light, which is going to tell us when our IMU is synchronized, and we have enough satellites are visible via that Trimble antenna. We have a log light that's going to help record our data to a separate USB that's separate from the Trinity F90 Plus. And then it's a simple one-button operation. You click the button to start recording, take your drone off. Once your drone lands, you click it to stop recording. It's really simple. Here's the general workflow on what your data is going to look like and how you're going to actually fly the Trinity. Obviously, we're going to plan a flight plan. That's going to be in Cubase 3D flight planning software, the free software included with the Trinity F90 Plus. Then we're going to do the data capture, which is going to be our one-button operation on the Qube 240 and our VTOL fixed-wing drone. Then we're going to process the data, and that's going to be done through a Planix postback for georeferencing and YellowScan CloudStation for our actual alignment, strip adjustment, classification, and more. And then afterwards, we're going to have our output, which is all going to be outputted through YellowScan CloudStation. We can output our LAS, LAZ, our terrain models, and really customize our coordinate system to then go into any other third-party softwares if you want, or take the deliverables right out of CloudStation. Completely up to you. So let's go over Cubase 3D and the flight planning software really briefly, just so you guys have an idea of what it's going to look like. So some general features. It is a Windows 10 based flight planning software. Again, there is no additional cost to it as of now. You get unlimited licenses. I can download this on 100 different computers if I want and transfer my flight plans around. It's your all-in-one software for flight planning, flight monitoring, and geotagging, except for the Qube 240, because again, it is a self-sufficient system. You can do area mission planning, corridor mission planning. You do 3D views, and you can even plan custom flight paths for really, really unique missions. And you can get really customized on how you want to build in the software. Now, just to highlight a couple of key points, and again, if you guys want more information on Cubase, we can send you the download link, and we can run you through some additional demos and screen shares. But there is terrain following, so we can download our elevation data, and you can see that it's basically a grid-based system where I can essentially click any of those open grids. As soon as it turns green, I then have elevation for that area. We also have a custom elevation data import supported, so I can import my own DTM in a TIFF file in WGS84, and then that way on sites where maybe I'm too far north, there's no terrain data, or I'm on like a mine site that's constantly changing or something getting excavated, I can then use this and import regular TIFF files to have proper terrain following and make sure my drone's following a nice and safe flight plan. You can see here's a good example in Iqaluit. We imported some terrain data where there traditionally would be none, so it traditionally just show flat in the 3D view, and you can now see the hills and the mountains, and our drone will obviously respond according to that. So area planning, again, just very generic. We can import KMLs or shape files. There's some custom features like setting entry or exit extensions for optimal line entry, and that's just to make sure our drone hits our flight lines nice and straight. We also have terrain following parameters, which we're going to go over in a little bit. And you can just optimize the leg sequence if you want. So your drones it's very smart. So it's going to auto-generate the most efficient path. And what's important to note is that no matter how well you flight plan, if your weather conditions change in the air, your drone is automatically going to choose the best and optimal flight path. So it may bank a little bit harder depending on wind conditions in the actual environment. So calibration loop. So Quantum Systems built in the calibration loop procedure in the software already. So there's little work that you have to do in the field. All you got to do is to make sure your IMU is correctly initialized. We have to create a initialization figure at the beginning and the end of your flight. And obviously the objective is to have enough acceleration to initiate the IMU, make sure that it's nice between the start and the end, and then we're gonna get really, really accurate data. So terrain following. So you have several terrain following options in the Trinity F90 Plus, which makes it so safe for really unique situations. A couple ones to highlight is the advanced terrain following option is going to place a multitude of waypoints along our mission. So you can see it if the video is playing proper for you. You can see when you change it, the above takeoff level map is going to follow a much more similar elevation to what the ground is showing, or we have a couple other options as well, depending on what your terrain is. So you can make sure you're nice and safe no matter where you're flying in any condition. So here's just a quick example of a Cubase mission planned pre-flight and then the post-pack recorded trajectory. So it's a really good indicator of how closely our actual mission planning is to what our drone flies in the field. It's almost exact. And obviously this is going to vary depending on a number of conditions and weather and wind, but this is it shows you how closely the mission planning actually works. So then after we're done our mission, we take off our drone, we upload the mission, and our drone takes off vertically and then transitions to a cruise mode at our transition height. So you can see in the video here, again, if it's playing well for you, how it just takes off straight up and then transitions, and it's really safe and you can avoid any trees or obstacles. While your drone is flying, we always have the monitoring mode. So we can actually always see where our Trinity is on the map. At the top of the video, you can see all the green sensors, so we can make sure that all of our sensors are working properly, our IMU, our motors, our speed, everything. And we also do get a general camera information if we're using one of the RGB or multi-spectral payloads. Lastly, our drone is going to come down and land. It's going to do the same procedure as the takeoff, where it's going to go from hover to cruise to hover mode, and then come straight down over our landing location. If you can see in the video how closely that Trinity lands right to the location of where it took off, it's almost exact. But again, you always have manual control to steer it left, right, forward, back, and do some minor adjustments if you have to guide it somewhere safe. And then after our flight, we're always left with 3 files. An LVX file, which is our raw LiDAR data produced from our Livebox Avia. You can see that the size is quite substantial on that. We have our T04 file, which is our inertial data, our trajectory file, and then our APX, which is our decimated trajectory file used by YellowScan CloudStation. So 3 files is all we get for each flight. And now what we're going to do is we're going to go quickly over the processing, and just to keep it interesting, we're just going to highlight the key points that everybody wants to know. So the processing workflow is very streamlined. We essentially are going to set our base location, verify our lever arms, and then export our SBET in between running the inertial processor front and back loop. So a couple things about a Planix post-pack UAV. It is a Trimble product, so you will notice it looks very similar to a lot of the other Trimble desktop softwares. In order to get the highest point cloud accuracy, we have to correct the trajectory. And this consists of a differential GNSS process using our base station, and it's a forward and backward inertial processing loop. So we have a couple different processing options based on how we want to set our base data. And this is really important for us getting the absolute highest accuracy possible. So we have one, which is on a landmark provided by the client. So this is if I have a known survey point or a pin somewhere near my site, I can put my base station. Again, doesn't matter if it's iBase or your Trimble R10, we can put it over a known pin. Second is we can post-process it. So because it's a Trimble product, we have the PPRTX correction service built in. So if you have a subscription for that, you can use the satellite correction service to correct your trajectory file and get that higher accuracy. Or we can use another PPE solution like Intercam PPP. We can post-process our base data in Canada and get that accurate location from there. Lastly, we have floating. So this will be no post-processing required. And this is basically going to leave you with not optimal accuracy, but it's available if you just need like a general layout of your land or something like that. We'll then be able to set our export settings. And the only reason I want to show everybody this is because we have custom coordinate system export. So you can see here, we have all the Canadian geodes built in. For example, I select the Canadian geode HT2 here, and then I can select my mapping frame. So for us, most of my clients are using NAT83 CSRS, and then it'll auto select the UTM zone that it was flown in automatically for you. But if you have a more custom system, we can import that as well. After we're done in PostPack, we then go to YellowScan CloudStation. So YellowScan CloudStation is, of course, a YellowScan product and works with the YellowScan systems. And essentially what we're going to do is we're going to drag in our trajectory file, that APX file. And you'll notice it looks really similar to what we saw in PostPack, but this is where we're actually going to select our flight lines to apply our trajectory data to the raw LiDAR point cloud and then visualize it. Now, because of the Trinity F90 Plus does bank on the turns and it's a fixed state system, we really recommend to not include the turns on the lines and just include the straight lines to make sure our data is nice and linear. Next, we'll do the strip alignment. Basically, it's an algorithm that's going to modify our position of points in the point cloud to optimize coherence between the strips and align our data much better. You'll notice that you only have two options in CloudStation. It's either robust or it's precise. If you're doing an area, you'll choose robust. If you're doing a corridor, you choose precise. We strongly recommend you always use strip alignment for every project, and that's just to maximize your accuracy and your precision no matter what. Again, with a fixed wing flight, we're typically going to generate about 10 to 40 gigabytes of data, and the processing time is going to vary depending on that. So if you can see in the video there, you'll see it give us a little misadjustment where we went from 16 centimeters to 7 centimeters. And that's just their calculations where they're going to narrow down the accuracy and the precision for us. Next, you can import GCPs, and a lot of customers like to do this to maximize accuracy. So basically, this is going to help with our methods to converge towards a more accurate solution. So unlike photogrammetry, where I can go and select the exact middle of my ground control point, you cannot really do that in LiDAR data based on the point cloud. So basically, it uses algorithms on and around the GCP. It takes that all into account to help improve our accuracy to those ground control points. So you got to make sure you set them on a very planar surface, nothing crazy, no edges. But it's a really simple, intuitive user interface. All I do is choose my GCP projection, import my text file, and I'm ready to go. And that's all I have to do. Next is the terrain classification. So this is basically the algorithms where we're going to choose, the software is going to automatically select whether points are ground versus non-ground. Now, there's a couple parameters we're not going to get too far into, where you saw, myself measuring some points on the ground there. But basically, this is really highly recommended because it's going to do a really good job classifying our points as non-ground. And then it's going to let us export out our terrain models right after that, because we now have points that are classified as only ground, remove all of our vegetation. Next is the export. So after this, we're going to export basically anything we need. So we can export an LES or LEZ in 1.2 or 1.4. We can export a DTM, DSM, DHM, and a hill shade model. We can completely choose our EPSG code and any coordinate system we need. What's really important is your height model will be taken from PostPack. So that's why it's really important to choose that HT version 2 with PostPack. And then we're going to export out the data as we see fit. And then we can then bring the data into any sort of software we need. You're going to have your LAS or LAZ, and then we're going to also export a DSM, DTM, DHM, or a hillshade model. Perfect. So I hope you guys saw quickly, before we continue on here, how easy the post-processing really is. YellowScan did a really good job of making it very streamlined and user-friendly and intuitive, yet still having the functionality to really give you that high accuracy data, which is what we're all looking for. So a couple of case studies just to go over some data. This is Saskatchewan Polytechnic. They acquired a Trinity F90 Plus and Qube 240 LiDAR payload to detect small changes in elevation and topography at really high resolution. So this particular data set that you guys kind of saw throughout the PowerPoint was used to test the efficacy of LiDAR in the boreal forest by flying plots for study for soil treatment. So basically what they really wanted to see was what is the drainage runoff on these sites due to the soil type, and how can we obviously categorize that. So you can see here, there was their LiDAR flight they planned, only a 12-minute LiDAR flight, very small. And then the photogrammetry flight on the right side, it was an 18-minute photogrammetry flight, both covering that exact same 22 hectares. So the area of interest was identical between the two. Total battery between the two was, again, 20% and 20%. Obviously, that matches and will be similar to what the flight times relate to versus 90 minutes versus 60 minutes. And the overlap on this was 50% for the LiDAR and 75-75 on the RX1, R2. Once we processed our LiDAR data, this is what it looks like. So you can see our actual area cover was about 61 hectares. So much, much larger than what that area of interest was, obviously, and that's cut out with the areas here. I purposely did not trim this LiDAR data so you could see what you can get on some of the data sets where your Trinity is banking, and you get much more area coverage than what you would expect. So what I would do is I would go in and obviously cut out this data set and make sure it's only containing the area of interest that I'm actually looking for. Next, we processed the RGB data, and then we completely overlaid that RGB orthophoto right on our LiDAR data. And you can see the difference in size between the two, and also the quality of the LiDAR data and how it's placed over our, the photogrammetry over the LiDAR. So that's just some quick examples from SAS Polytech and what they did. The data looks really, really good. Next thing is a LiDAR survey in the high Arctic. So this was a really good test done by Arctic UAV, who owns a Trinity with a Qube 240 LiDAR payload. They worked with a municipality in northern Nunavut, and they successfully mapped about 750 hectares of road areas that are to a nearby lake that the municipality was proposing. So the problems with this mission was that the travel to the site was only accessible by helicopter. We had really high winds and conditions were really harsh and took a ton of planning and preparations. You can kind of see Kurt's quote there where the project saved their customer over $100,000 over traditional helicopter and external LiDAR systems. So it's a perfect use case on why a fixed wing LiDAR unit and the ROI is much, much better than traditional manned helicopter LiDAR data in some situations. You can see here, the remote area of interest meant that they had to take a helicopter, the UAV equipment slung below to the remote area in northern Nunavut. 5 to 12 meters per second winds limited when they could fly the helicopter as well as the drones. The area was only accessible by helicopter, so it had to be performed as needed on each day perfectly, or else they were going to miss their opportunity. And lastly, the data here on this one, you can kind of see you get about 750 hectares, is about a 500 meter by 15 kilometer corridor. 21 flights total. They did about 10 flights with the Qube 240 LiDAR, another 11 with RGB data. They did separate flights done for photogrammetry and LiDAR. All flights were done within visual line of sight and obviously following Transport Canada's rules. Both 30 to 40 minutes per flight just due to the wind conditions and being extra safe. They traveled by helicopter every 3 to 4 kilometers, and the project was completed in just over 1 week to get all of that data set. So a very large data. Obviously, they then had to lower the point density to make sure you could pass it on to your client appropriately, but the data looked really, really good in terms of mapped exactly what they wanted to do. And our last case study is actually out of Africa. So it was Rocket Mine in partnership with Quantum Systems. And this is where the Newmont gold mine, they tasked Rocket Mine to map their mining lease, which is covered in really dense canopy, so you couldn't send traditional survey crews. They needed a DTM of over 6,500 hectares to plan protection measures in the event of a dam collapse. So there was multiple villages in the area below the dam that they had to map how would the water flow if the dam did collapse, and are these villages in the area that would be wiped out basically by that. So they did a quick mission plan, 20 flights at 100 to 120 meters AGL, 55 to 60 minutes of flight time. Obviously, in those warmer weather conditions, tropical conditions, they get extended flight times as well to really maximize that. They had 6 takeoff locations with 5 flights per day, and again, covered 6,500 hectares. So here's a really good picture showing day 1, day 2, day 3, and then day 4, where they basically covered all of it in only 4 days. Here's just a sample subset of the data, a nice point cloud and some raw ground points, so you can see the terrain data. Just a really, really small subset of the overall data set. And then they ran a couple of elevation checks. So they ran 3 subsets of the data they shot with GNSS RTK, all taken on open terrain, and they were averaged over multiple readings. They got about a 2.3 centimeter delta on the elevation. Now, I always precaution people and tell people that, on a data set like this, obviously we need many, many more control points to really give a really good accuracy check. But it's just a really good starting indicator to see what were accuracy checks around this area. And lastly, the final results was total about 19 hours of flight time, 11.1 billion points with 2.6 billion ground points. So we got about 40 points per square meter ground density, point density through that canopy, which is really, really good. And then we resampled to 4 points per square meter, and then the risk assessment was built based on this data. And lastly, just 2 more slides before we're done here. What comes in the Trinity box? Everything that I talked about is included. There's no optional accessories. $26,500, and you're basically up and running with the Trinity F90 Plus without a payload. And then in the box for the Qube 240, we do get that Trimble GPS antenna, 2 flash drives. But what's really important about the Qube 240 is we actually get 2 licenses. We get the annual CloudStation core license and the strip adjustment license included with it. So there's not a lot of additional cost for software on top of this. And obviously, if you want pricing on the Qube 240, please contact Measure or myself, and we'll be happy to help you out. So I know that was a really quick run through, but I tried to keep it around that 30 minutes. I ran a little bit over. So if anybody's stuck around here, we'll probably answer some quick questions once I close let me just stop this here. Perfect. All right, so we can answer some quick questions here that I have for everybody. And I'd like to go through them all. And again, we won't answer all of them, but just give us about 5 minutes here. So we have a couple. How many propellers spin during the cruise mode? So in cruise mode, only the back propeller spins. So that's how they get the absolute longest flight time. All 3 spin during hover, takeoff, and landing, but only 1 back motor spins during cruise mode. Cost of the processing softwares. We'll provide official quotes to anybody who wants costing on any item. So we'll mark down everybody who sent in questions here, and then I will basically send you official quotes from whoever your sales rep is in that territory. I see we have some people here. So do you anticipate 3 returns to penetrate tall grass, or is it more designed to penetrate tree canopies? So it's really both. Extra returns in the general sense is going to give you a better chance to penetrate canopy. Now, there are certain conditions that make LiDAR a little bit tougher, something like prairie grass in Saskatchewan and, some of that really wispy grass. But in general, the more returns you have, the better chance. So if you traditionally used a 2-return system or just photogrammetry, you will have a better chance to get to the ground and through that grass, even if it is tall grass. Can you control the takeoff, landing, and transition to VTOL to forward flight manually, or only through the flight planning software? So you can transition manually. So when you are in manual mode, say in cruise mode, I can actually turn my drone to hover and land it. There's just some parameters which I won't go over right away, but they're basically, you basically have parameters in terms of when you can hover and how close to home point you are allowed to be. So you can transitioning from hover to cruise, you can also do. It's just not recommended, and we recommend just obviously following the flight planning software, but it is available if you absolutely have to. What process is recommended to get a RGB colored point cloud using the LiDAR data? Second flight with an RGB camera? Exactly. So because of the weight of the Qube 240, you can't have an RGB camera attached onto the back of it. So we really recommend running 2 flights. Traditionally, if you're just trying to colorize your LiDAR data, I'd recommend flying with the lower resolution 20 megapixel camera, because we don't need that higher resolution just for colorization. So you can just do 1 flight with the LiDAR system and then 1 flight with like the Sony UMC at a lower overlap. And then that way we can just do a quick stitch and then stitch it right on top in something like Cloud Compare or another software. What are the emergency contingency procedures? Yes, so there are several built-in features and contingency procedures, including all the return to home functionality where, if it's too high of winds, our drone's going to return home automatically. If our drone notices unequal battery levels or a motor thrust error, anything like that, it's going to auto return home or transition to hover and do an emergency landing, depending how severe it is. And then we have a couple of manual controls that we can set, like I have a return to home button on both my RC and my Cubase. So you have 2 options to return your drone home. I have an eagle mode, which sends your drone into a really steep ascent to make sure that there are no eagles attacking your drone, because they don't like that. So there's lots of built-in emergency contingency procedures, and we can send you a clarification on all that via email with all the exacts. So more license questions, which again, we'll respond back to you guys directly on that, because then we can give you full pricing depending on if it's perpetual, annual, maintenance fees, all that. Is there a full motion video option available, or is it still image capture only? right now, with any of the RGB cameras, they are still image captures. Theoretically, I could power our cameras by the external. I could, for example, take my RX1 with an external battery, put it in there, and then start record on the ground and take off, and then set my Trinity as having no payload. But it's kind of just a workaround that's not recommended. The drone is a fixed wing drone meant for surveying and mapping. Does the LiDAR unit require in-air calibration, doing figure eights and U-shape prior to starting the mission flight? So we kind of went over that a bit. Yes, we're going to do that forward, back, forward, before and after your mission every single time to make sure that it's nice and calibrated and our IMU is nice and initialized. So yes, it is required if you want optimal accuracy and data, or else we risk IMU drift, especially on a fixed wing drone where traditionally our flight lines are much, much longer than usual. What is the maximum realistic range of that AV LiDAR? Is 100 meters the max AGL for nominal reflective targets? Yes, 100 meters is the maximum. Anything above 100 meters, we start losing out on point density and accuracy. So really that 100 meters is kind of the sweet spot that you want to keep. Obviously, we can lower it if we want to increase point density, but in terms of normal reflective targets, 100 meters is definitely the go-to, yes. To have a colorized point cloud, we require 2 separate flights. I kind of just talked about that really briefly, but yes, 2 separate flights. Again, I can colorize my LiDAR data with anything as well, though. So if I want to use satellite data to colorize my LiDAR, if I want to use a manned aircraft, if I want to use publicly available images, you can colorize it with absolutely anything. As long as it's an ortho photo, we can do it no problem. Could you do a comparison for area coverage between a Mavic style quadcopter and the Trinity on one charge? Yeah, we can send you we have a couple of write-ups on the difference between all of them. So we can definitely go over all that in an email to you, but I would like to, have the time to write that up for you so that we're properly following and not just spitting out random numbers. Is there any RTK capability yet or just PPK only still? It's only PPK'd. I strongly recommend PPK over RTK, especially for LiDAR data, because RTK, there's lots of opportunities to have slippage. And, even if you have 3, 4, 5, 10 seconds without RTK, we now have, hundreds of thousands of points that are not georeferenced or not as accurate. So I really want the PPK pretty much guarantees that we're going to have a really high, 99, 100% fix at all times if we follow the proper procedures. So I always recommend PPK. There is no RTK capability. What do you use to process the data? So the processing the data was done via the Planix postpack and the CloudStation. It is perpetual or annual, and we can send you pricing on some of those licenses. Sorry, guys, I got a couple more questions here. What is the RGB camera cost? It completely depends which RGB camera you want. If you go to our website, drones.measure.ca, all Trinity payloads are on there, and the pricing is on there. So if you want to quickly run through and see what it's going to cost for a 42 megapixel or 20 megapixel, it is on there. We'll be interested in So any possibility of future integrations? So yes, they're working on a lot of really cool stuff, just stuff that we cannot necessarily say. But if you have a specific payload that you want integrated, please email us and let us know, and we'll forward that information to Quantum Systems. And then that way their development team, once they get enough requests, they can do it fairly easily. Can all processing be done right in Business Center? So TBC is a separate platform from the Planix postback, even though they're both owned by Trimble. But you can bring your LiDAR data right into TBC afterwards and do all your data manipulation, strip adjustment, everything like that. Do we have a physical office in Montreal? We do. I can get you in contact with Pierre, who is our Montreal drone rep, and he is fantastic, and he'd be more than happy to help you out. Can the drone fly connectionless? Yes. The Trinity can fly for X amount of seconds with loss of both RC and telemetry. So essentially, we can fly blind for a predetermined amount of seconds. We can set this anywhere from 10 seconds all the way up to 9,999 seconds if you really want. Which obviously Transport Canada is not going to be too happy with you if you try to do that. But yes, you can fly connectionless, so then you can give yourself enough buffer room. What are the emergency procedures if power is lost on the aircraft? Is it designed to glide to the ground? Yes, so the Trinity in any sort of super emergency situation, basically the last fail-safe is a controlled spiral to the ground. Now, in an emergency procedure, regardless of what your drone is, obviously there's going to be damage to your drone, but it will spiral and glide as best as it can. Okay, 2 more questions here. Yes, you can use Agisoft Metashape for your 3D models. So CloudStation and Postback are not photogrammetry software. So all photogrammetry can still be done in Pix4D, Agisoft, Correlator 3D, you name it. It's all going to be in any separate software that you want. Is there plans to allow for multiple controllers to be paired to one drone, allowing handoffs? Yes, this is in the works. I will reach out to Quantum Systems and get a better estimation on when this will be available. And obviously, this is super important to the future of BVLOS and even larger area mapping. What is the max takeoff wind speed for the LiDAR system? So the max takeoff wind speed for the LiDAR system, so it'll be just under that 9 meters per second. It's not 5 meters per second. It's about 7.5 meters per second. So it's lowered a little bit on the ground just due to the much heavier weight and power system. And then lastly, availability on systems. Trinity F90 Pluses are in stock. Most photogrammetry sensors are ready to go. And Qube 240 LiDARs are about 6 weeks, give or take, depending on when you order and how many we have coming in. So it's about a 6 week for the LiDAR, and Trinities are ready to go tomorrow if you really want one. And I think that's all the questions. Perfect, everybody. I really appreciate all of the attendance and everybody really sending their questions. Those are all really good questions. Again, if you have more and you want more additional information, demos, in-person, data, anything, please send an email to contact@measure.ca, visit our drone website, give us a call, and we'll distribute you to the appropriate drone rep who can give you all the information you need. Awesome. Thank you so much, everybody. And I hope everybody has a great rest of your day.